All right, hello and welcome. This is our part two of our journey through chapter 19 in the Modeling Our World curriculum. We are focusing on confidence intervals for proportions. And in this video, we are just going to do we're going to do two example problems. And then the second example problem, we're going to work on how you determine the critical z-score for a certain confidence level. Okay? So here's our first question. Our first question is, in a Harvard School of Public Health survey, 2,105 of the 10,904 randomly selected U.S. college students were classified as abstainers or non-drinkers. So the question here is asking us to construct and interpret a 95% confidence interval for P. So remember, anytime we're doing confidence intervals or a hypothesis test, we're going to have to do certain assumptions and conditions in order to be able to use this particular test. And the assumptions and conditions that we need for this test, and again, this is simply the AP Board's requirements, is do we have random data and is our sample size large enough? So let's look at those two things first. Do we have random data? And so I look back at my problem stem here and look at that. It says that they will randomly select it. So we do. So we can say the problem stem states that the data was collected randomly. And that statement shows that we checked the randomness assumption and that it's okay. It was done randomly, so that's good. The second one here is our sample size. And remember, the sample size for a proportion means that NP has to be greater than 10 and NQ has to be greater than 10, where P and Q are the number of successes and the number of failures. So in our case, we have 2,105 successes and whatever 2,105 minus the 10,000 minus that is. So that's, let's see, head here. Minusing 5 brings me to 899. Minusing 100 brings me to 799. Minusing 2,000 brings me to 8,799. So we have 8,799 fails. Both are greater than 10. So the sample size is large enough. And I'm running out of room, of course, but there we go, right? So the sample size is large enough because we have more than 10 successes and failures. With a sample size of 10,904, we would have to have an awfully small number of successes in order for this not to be big enough. So these are both way bigger than 10. Sample size is great. Okay, so assumptions and conditions have been met. We can use this to construct a 1 prop z interval. So that is the confidence interval that we are creating. So the next thing we want to do here is our mechanics. And our mechanics are the actual construction of the confidence interval. Now, our formula for that is p hat plus or minus the critical z-score times the square root of p hat q hat over n. And we have all of those values in front of us. We can plug those particular things in and we can figure that out. However, we can do this on the calculator as well, right? So we can actually use a TI-84, TI-83, or a number of other statistical softwares to do this. And so let's do that. So I'm going to back out of this PowerPoint real quick. Let's hold these so they don't go away. You can see those right over. And let's take a look at our calculator. So move this over here. On your calculator, when you turn it on, we need to go to the Stat button and then over to the Tests. And what we're looking for is that one prop z interval. So we're going to go down until we find one prop z interval, and it turns out that that one is on the A listing. So I'm going to hit enter on one prop z interval. This is data from a different problem, so we'll delete that real quick. Maybe. Oh, we'll write over it. So the x value is the number of successes. In this case, that's the 2,105. And then the n value is our sample size, so that's the 10,904. And the confidence level is a 95% confidence, because they said 95% confidence, so we'll leave that at 0.95. And we will calculate it, and that is our interval, 0.185 to 0.200. So that is 18.5% to 20.04. So let's remember those, 18.5 to 20.04. 18.5. So our interval is, 18.5 to 20.04%. And so we have completed enough of this. Now, if you're in the AP course and what needs to be seen on the AP test, they need to see the, you're going to want to name the test you're doing, one prop z interval. You can put the formula there, though not required. The other thing that you can do is you can literally just copy what you wrote on that wizard. So you can be like x equals 2105, n equals 10904, and the confidence level is 0.95. And that is considered showing your work, right? You can't see it on the screen, but I'm doing quotes. I'm doing air quotes. That's showing your work. And I think one of the main reasons why they classify that as showing your work is because the reality of life is that nobody does this stuff by hand. It's always done on calculators or statistical software. And so we want to encourage you to be using the tools that they actually use in real life. Because, yeah, nobody does statistics by hand, because that's just me, right? Okay, so we've got assumptions and conditions done. We have our mechanics done. The final thing that we need to write here is our conclusion. And our conclusion is a statement that states the level of confidence, it states the interval, and it states the context of the problem. I'm going to erase this here real quick so we can see this. So let's write it all down. So we are 95% confident. And so there's me stating my confidence. I'm 95% confident that, and let's state our context here, the percent of college students who abstain from alcohol, that the percent of students, and I should say the percent of college students probably, who abstain from alcohol is between 18.5% and 20.04%. So based on our particular sample, we have a confidence interval of 18.5% to 20.04%. Again, what that means is that if I were to do repeated sampling, I am 95% confident. So that means that 95% of the confidence intervals I create will capture the true proportion between 18.5 and 20.04. I'm 95% confident that 95% of the samples taken will capture the true proportion between 18.5 and 20.04%. Okay? That's what that means. And there we are. There we're done. We have all of that info done. Let's answer the next question. We can kind of read that. A newspaper article claims that 25% of U.S. college students are non-drinkers. Use your result from A to comment on this claim. So our confidence interval says that it's between 18.5% and 20.04%. So somebody making the claim that 25% of U.S. college students are non-drinkers, we're going to say that that's not an accurate claim, right? This claim is not accurate, and it's not accurate because we would expect random sampling to tell us that 95% of samples taken will give us a result between 18.5% and 20.04%. Okay, that's going to be captured in there. So no, this is not an accurate claim because our confidence interval says it's between 18.5 and 20.04. We're 95% confident of that, and so 25% not an accurate claim. So if you've got questions on that, you can make sure. Can I erase this stuff anymore? I don't think I can. I think it's permanent. I gotta figure out how to do that. If you got comments on that, feel free to leave them in the comments. Otherwise, let's go to the next question, which is actually back a question, and we are going to answer this one. So the Skagit Valley Herald pulls a random sample of 330 voters, finding 144 who say they will vote yes on the upcoming levy vote. Create a 90% confidence interval for the actual sentiment of all voters. So, like normal, this is in 3 steps: assumptions and conditions first, mechanics second, and then the actual thing, your conclusion last. So this is what we're making a confidence interval for. Let's talk about our assumptions and conditions. Again, these are all of them. We should talk about independence and 10%, less than 10%. Remember, the AP test only requires these two. Is it random? Is it success failure? So let's answer just those ones first. Do we have randomness? States right there that it's a random sample. So I'm going to write an entire sentence, right? The question stem states that the sample is random. So that covers our randomization condition. That one's good. The next one is our sample size. Do we have enough successes and failures? So that's NP greater than 10 and NQ greater than 10. Our NP is 144, and our NQ, because that's our number who say they will vote yes. Our NQ is the number that will vote no, so I got to do a little subtraction here. 330 minus 144, so that's 230, 190, 186. So both NP and NQ are greater than 10. So our sample size is large enough. Okay, so that covers that condition. And then the thing we might add to the end of that is the conditions are met to use the normal model for a 1 proportion z interval, or like we said in the last one, a 1 prop z interval. So there's our assumptions and conditions. Now let's move on to the mechanics. So our sample size is 330. This makes our p hat, because it's 144 divided by 330, to be 0.436. So there's our standard error, our our little margin of error. 1.64, that's our critical z-score, and we will take to the calculator here in a moment to tell you how we got that number. But there's our interval, 0.392 to 0.48. I'm going to back out of this again real quick, and let's show that on the calculator. So we're going to turn that on. We're going to go to stat, test, 1 prop z, interval. In this case, our x is 144. Our sample size is 330. And this time our confidence level is 0.90. So we're going to calculate that, and we end up with that same number. We rounded it here, but 0.39146 to 0.48127, and that's what those are rounded right there. Okay. Let's talk for a second about how we got this. How we got this 1.64 as the critical z-score. So the critical z-scores, these scores are they're a z-score, right? It's the z-score that represents the margin that creates a 90% confidence interval. So this is my normal model, right? A 95% confidence interval means that the middle 90% is what we're looking for, right? The middle 90% is what creates a 90% confidence interval. So I need to take this value in here, and I need to find the z-score that is associated. Like if this is my 90% right here, I need to find the z-score that is associated with that spot. Okay? And we have a calculator command for that we already did. We know the percent. So we know that going from percent to a z-score, the command we use is inverse norm. Now we have to be a little bit tricky about how we do this, because this is the strange part. This is the part that we have to get used to, okay? The middle 90% is what we're taking the confidence interval of. But when we use inverse norm, the inverse norm command does not take the middle 90%. The inverse norm command takes from the beginning all the way to the left, and it fills it in, finding area until it reaches 0.9, and then it stops. Okay? The problem with this is the middle 90% doesn't contain this area over here. So when you use inverse norm, you're going to get if you do inverse norm of 0.9, you're going to get the wrong answer, because it's going to count something over here because it's adding this stuff up. So what we have to do is trick our calculators. This is the middle 90% right here. But to find the z-score that is associated here, we have to trick our calculator to take the middle 90% plus this percent over here. And so if this middle area is 90%, what's on the two outsides? 5%, 90%, 5%. So the actual command we want to do is not inverse norm of 0.9. It's inverse norm of 0.95, because it's the middle 90% plus the 5%. We're tricking our calculators into giving us the right number. So to find a 90% confidence, we need to do inverse norm for 0.95, because we're taking the middle 90% plus the 5% over here that didn't get answered. So when we do that, we do inverse norm. Oh, I gotta get back to my mouse here. Sorry. There we go. We do second vars, inverse norm, and then we do 0.95. And you'll notice that when we do 0.95, it gives us the 1.64 that we had before, right? Again, we use 1.96 for a 95% confidence interval. If we're doing 95% confidence, to find that we need to do inverse norm of 0.975. And the reason we do that is because we're taking the middle 95%, which leaves 2.5% on both sides. We need, our inverse norm command is looking for this spot, so we need to take the 2.5% that's here, plus the 95% that's here, in order to get that exact spot, which is 0.975. And again, I'll just show you that point. If we do inverse norm of 0.975, we get the 1.96. That's 5 rounded that we were looking for. Okay, so there's a quick how we find the confidence level, that z-score. Again, questions, comments, leave them in the comments section. We'll do our best to help you out. Let's finish the last of this this problem here. So we found our confidence interval to be 0.392. There's our mechanics. The last step is our conclusion, in which case we say we are approximately 90% confident. State your confidence. That between 39.2% and 48% of voters, state your interval, will vote yes on the upcoming budget. State your context, right? Confidence, interval, context. And that's all we got for this video. Again, questions, comments, concerns, you can leave them in the comments section, and I'll do my best to help you out. Other than that,